So, so the next topic is on simple trusses. So you may be asking, what is a simple truss, and why do we use trusses at all? So trusses are structures that are composed of slender members. So what I mean by slender is that the length of the member is much greater than the member's width or the member's thickness. All right? So the benefits of using a truss is that a truss is very strong for its weight. All right, so it maximizes strength to weight. All right, so and then reduced weight also lowers cost. All right. So trusses are great for high strength to weight ratios, which makes them ideal for structures such as roofs. So we have an example of a roof truss on the top of our screen here. All right. So this roof truss has two trusses that are connected together using long beams. These long beams are called purlins. All right, and the purlins, what they will do is they'll take the load due to the weight of the roof, and they will transmit that load to the joints of the truss. All right, and then those joints that are applied to the truss are distributed within the forces within the truss, or within the members of the truss, and that is what allows the truss to hold so much weight, is that the forces are directly applied to the members, and it helps distribute the load evenly throughout those members. All right. So a very similar structure is that for a truss bridge. So typically you have some weight is applied, or some forces are being applied to the deck of your bridge. All right. And then that weight gets transmitted through stringers and floor beams to our truss. All right, so it gets transmitted to our truss, and you can see those forces being applied here at the truss edges. All right, so what trusses help do is they help take all these vertical forces and they help distribute them up into a vertical direction. So they help deal with large vertical forces, and yeah. So they help using a very small amount of weight. You can span a very large distance without using too much weight, or with having any supporting structures underneath the bridge. All right, so what we're going to be interested in for trusses is we're want to know is what are the forces within each member of our truss. All right, so that is our goal for these videos, is to try to determine what are the forces within each of these trusses. All right, so the reason we are interested in determining the forces is if we know the forces within each of the truss members, what we can then do is we can appropriately pick the materials and the size of the material, the members needed to construct the truss. All right. So for a truss, we're going to make some assumptions that will help us or simplify our analysis. So the first assumption that we're going to make is that all loading will be applied at the joints. So we can have two cases. The first case is if we ignore the weight of all the members of all the truss members. Alright, so in that case, we will say is that all loads will be transmitted to the truss through the joints. Alright. The second thing is if we want to include the weight of the truss, so if weight is included, what we will do is we will divide the weight of the member by 2 and apply that weight at each joint. Right? So the second assumption we're going to make for trusses is that all the members will be connected together by smooth pins. Right? So in the case of, so we have two cases of connections that are common in truss structures. We have gusset plates, which are used to connect different members within a truss, or sometimes the members within a truss are pinned or bolted together. So in either case, what we can say is that all the forces will be concurrent. So in both cases, all forces are concurrent. Alright, and what that means is that all the forces go through a common point. Alright, so all the forces are going through the joint directly. Now that's significant because since all the forces act through the same point, no moments would be generated. So the connections at pins will only need to resist translational motion or forces. Right? So pins are appropriate because of that, and then we can say that a truss member will either be in tension or compression. Right? So the reason the direction or whether a member is being in tension or compression is important is that typically members are much stronger in tension than in compression due to buckling. All right, so typically members that are in compression can buckle and fail under much smaller loads than the same load in tension. All right. So if we go to the next page here, I'll talk about a simple truss. Alright, so if you have any three joints that are pinned together in a triangular configuration, they will form a rigid truss. Alright, so if we look at this example here, or figure 6.5, That's an example, the simplest example of a rigid truss. And then you can make, if you combine, um, you combine any two members to our original truss here. So if we add two members, AD and DC here, alright, and we connect those two members at a new joint and two existing joints. So our new joint was joint D and our existing joints were A and C. We can still use, so for all these cases, since they're basically combinations of our most simple case, alright, we end up getting, because they're combinations of these simple cases where we just have pins at one point, we can say that what we're going to be able to do with these types of structures is we can use two methods to solve these problems. Alright, the first method we'll talk about later on during this lecture, and then the next one we'll talk around during the following lecture. So the first method we'll use is the method of joints, and then the second method we'll use is called the method of sections. So that concludes this video. In the next video we're going to talk about the method of joints. All right, so that's what we talk about during the next video.